Okay children, good morning. Welcome to the online class. I hope you remember what the sums we had done. In fact, we had completed 16 sums in the last lecture, in the last session. Now this is the 17th one because I felt that I am not that much happy or satisfied with whatever we had done till now. So I will just add some more examples of class 11. I would not say class 11. These are important things which you have to know to understand the complete differentiation of class 12. So I would say this is the part of class 12 syllabus. So basically this represents your first two exercises of your textbook for ISC board examination. So ladies and gentlemen, now here we go for solving further sums. So let us quickly go ahead with it. Now if you see carefully, it is nothing but u by v rule, right? So I think let us apply the u by v rule. Y dash will be v square. Now v square, everybody knows what it is. It is nothing but 4 minus x square. I am directly applying the formula. V derivative of u minus u derivative of v. I hope it is very clear. Now once this is done, I think I need to know where I stand, where I have to take the same terms, where I have to take the derivative. I am very clear about it. So let us go ahead with that. So y dash will be is equal to, this is square root of 4 minus x square into, what is derivative of x square? Power rule, x raised to n, nx n minus 1. So this will become 2x bracket, don't forget to put the bracket, x square into, now hold on, let us check out with this. Root of 4, root of anything. What is the derivative of root of anything? Root of anything derivative is 1 upon 2 root that thing. I hope it's very clear. So 1 upon 2 root 4 minus x square. Now hold on. Root of something is 1 upon 2 root that thing, right? The derivative. And when you go inside, this was the derivative of root. But when you go inside, there is an algebraic function. So as I said, when there is a function inside another function, you take the outside function derivative, then you take the inner derivative, then take the inner derivative. That is called as chain rule. So I took the root derivative. Now inside is 4 minus x square. So derivative of this will become minus 2x. I can definitely upon v square. I don't have to forget this part. Now I can cancel this 2 and these 2. Now let us see what happens. Now children, one thing I want you to observe here. If you look at the numerator, it is a little bit of cheeky thing there. So what I am going to do is, I can find the LCM of the numerator and simplify it out, right? So y dash, the LCM of the numerator will join the denominator and see what happens. Square root goes into 2x. Now minus of minus will become plus x cube. Be careful. Don't commit silly mistake here. This basic maths what is we are calling for. Okay. So here let us pursue this further because there might be some cause of like terms there. So what has happened now? See y dash, or you can also say dy by dx is equal to 4 to the 8x minus 2x cube plus x cube upon, that is, I can write this as 4 minus x square raised to 3 by 2. Now you must know how I got this raised to 3 by 2, because this is raised to half, right? See, it is square root of a into a. So this a is half into a raised to 1. So add the powers, 1 plus half is 3 by 2. So root a into a is always a raised to 3 by 2. So here root of 4 minus x square into 4 minus x square is 4 minus x square raised to 3 by 2, and here you can see the like terms clearly. So y dash, that is 8x minus x cube upon 4 minus x square raised to 3 by 2. If you want, you can take simplification further there. Y dash will be equal to, if I take x common here, this will become 8 minus x square upon 4 minus x square raised to 3 by 2. So this is the final solution. So as I said, I want to repeat this point that I want to take some more sums not related to class 11, just to do some sums applying the class 11 concept of derivative. We are going to study a lot of things in derivative in class 12. It is quite lengthy, but as I said, I want to remind you the next 4 topics: indeterminate forms of limit, mean value theorem, application of derivative, maxima, minima. These 4 topics are totally based on your understanding of this particular differentiation what we are studying in the core topic of differentiation. Okay, so please take it down and let me continue with the next question. Okay, children, the next question comes up. Now, this is slightly close to my heart because it has a really tough, not tough thing, but a lot of basic maths are put to test here. Your skill of basic mathematics is put to test. So, I'll just put first only, I'll just work out with the partition here because I know it's going to go towards the western side from east to west. Okay, so let us believe this now how to do. Now, first of all, I want to understand power. So, I had mentioned you earlier also, in derivative, whenever a function has power, the first thing you take the derivative is of the power by applying the power rule, irrespective of what function. It can be algebraic function, it can be trigonometric function, it can be log, it can be any damn thing. Raised to power, so first find the derivative of the power, that is the first derivative you have to find. So, y dash. So, y dash, if you see carefully here, this, suppose this is x, this complete, x raised to 4. Power rule. What is x raised to 4? 4x cube. So, 4x. X is this stuff. Now, this was the power derivative. I want to remind you about chain rule. Remember, when there is a box, inside another box, inside another box, inside another box, how you open and reach the innermost box? First you open the outer box, then you take the inner box, then you take the inner box. Same way here, take the outer derivative first, then you will find the derivative of the inside part, because outer derivative, this is a power ka derivative, but inside there is an algebraic function. Make a note of it. So, into chain rule says first outer derivative, then go inside and find the derivative. So, into derivative of, I am purposely writing this stuff, otherwise you might not follow later on what I did. So, now when you look here, I have nothing to do much. But when I look here, I have a lot of things to introspect. U by V rule. I hope you got this point. Yes, if you can simplify, go ahead and simplify. Nobody can stop you that part. Because this is a single function, you can simplify whatever feasibility of it is there. So, now let us do U by V again. So, let us talk about this y dash is equal to 4. This is nothing but x cube minus 1, 2x cube plus 1 whole cube. Nothing to do in this. Now, I will apply U by V rule. So, V square V, now derivative of U, make a note of this numerator, derivative of numerator. What is derivative of x cube? 3x square, and one derivative is 0. So, only 3x square minus, see, V derivative of U minus U derivative of V. I hope you got this point clear, because here the derivative 1 is 0. Now, once you finish with this, I think some like terms will crop up here. So, let us do the simplification what we are expected to do. So, y dash, this you can for the time being keep it as it is, because x raised to cube minus 1 upon 2x cube plus 1 raised to 3. Nothing to do over here, right, into. Now, pay attention here. Now, this is something important here, that is 2x cube plus 1 whole square. So, what I do? 2x cube plus 1 whole square. Don't touch this out. Now, 6x raised to 5, I am opening up, plus 3x square minus 6x cube into 3 is 6x5 and plus 6x square. So, I think I am somewhat comfortable here, but one thing I remember and understand from here, 6x5 and 6x5 gets cancelled. These are like terms here, right, and I go ahead with the, okay, you can just go ahead with the solution. So, y dash will be is equal to 4 times, this will become x cube minus 1 upon 2x cube plus 1 whole cube, hold on, into Now what happens into, look at it, 3x square plus 9, 6x square is 9x square upon 2x cube plus 1 raised to 2. Finish, my job is over. You can shrink this and simplify it further. I don't think so anything you can cancel this here. So I'll just mention this here. Now y dash will be is equal to numerator 4 into 9, 36 x square, right? And what happens here? This will become x cube minus 1 whole cube upon, I repeat, please pay attention, 9x, 9 into 4, 36 x square, x cube minus 1 cube. Now this is 3, remember this cube applies to both, cube and square, same thing. So that is nothing but 2x square plus 1 raised to 5, same base. This is my final solution for this particular question. I am not worried about this basic, I think you are well versed with that, and in case you do mistake, you will not do mistake later on definitely, because you will be doing the same basic mathematics again and again throughout derivative. What is important is that portion, that part. What is that part? That part is nothing but if you see this 4x cube minus 1 upon 2. So first find the derivative of 4, then inside derivative. That's what chain rule says. I hope you got this point clear. Okay, so pause and note it down. Okay guys, this is a very similar to the previous question, so let us pick it up very quickly. There are many ways to do. First is root of something is 1 upon that thing and all that stuff. So you can do, I think we will stick to that. Okay. First, y dash. So root of anything, see inside there is a single function, root of anything is 1 upon 2 root that thing. So 1 upon 2 root of 1 minus x upon 2 plus x into, hold your breath, root derivative is 1 upon 2 root, and inside there is again one function, this is the root derivative, then you take the inside derivative into derivative of, don't put root because you already found the derivative of the root, sorry, there is 1 minus x upon 2 plus x, chain rule. First root ka derivative, root of something is 1 upon 2 root that thing, and immediately derivative of the inside function 1 minus x upon 2 plus x. Keep in mind always, okay. Now once you do it, let us do this. I think you can shift this here up here. So y dash is square root of 2 plus x upon 2 root 1 minus x into. Now what I am going to do here is, please pay attention. In this case, I will do v square, u by v rule. Now pay attention, v. Now derivative of 1 minus x, derivative 1 is 0 and minus x derivative is minus 1, right. V derivative of u minus u derivative of v. I directly did the step because they are simple functions. So now I think I can, let us see what happens here. So y dash will be eventually 2 plus x upon 2 root 1 minus x. I am not touching this. Let me see what ends up in this simplification into. Now see here what happens. This will become minus 2 minus x minus 1 plus x upon 2 plus x whole square. So this cancels out completely. Right? So I give you 1 minute, complete this out quickly, fast. Okay, I think by this time you must have realized what to do. So let us see, y dash will become 2 plus x upon 2 root 1 minus x into, now see minus 2 minus 1 is minus 3 upon 2 plus x whole square. Now nothing much to do, you can cancel this if you want. Otherwise, I think it's better you can cancel because this will become, see, now I'll just show you. So, if I say this is a upon, this is root of a upon, this is a square. Just try to work on with that. So, this is root a. This a square I can write a into a, correct? This a I can write root a square. So 1 root a get cancelled, 1 root a get cancelled. Just the previous sum, what is a into root a? it is 1 upon a raised to 3 by 2. So, similarly here, if I want to apply the simplification, so y dash will become minus 3 by 2. This cancels with this part, okay, and this will remain as it is, root of 1 minus x. This will become 2 plus x raised to 3 by 2. So, this is what the final solution will look like. So, I hope you got this point clear, children. I hope I am carrying myself rightly, right. If in case any error happens at our end, please mention to us, because we want to rectify there and there itself. I hope you got this point clear. Nothing much to add. So, this is what is the pattern of chain rule, the full application. Okay. Now, let us see how we evolve more and more sums based on class 11 and the beginning of class 12, the first two exercises of your textbook. So, please, if those are not completed this, complete it up, and those who have done it, fine. Let us take the next question now. I believe most of you have done that. So, let us see. The next question comes up like this. Oh, that's very good. Look at the question now. I think there is nothing much to do in this question. They are very simple sums, but I just purposely took so that some chain derivative practice can happen. Now, if you look at this particular sum, now y is equal to sine 3x cos 5x. So, what I can do is, okay, what I can do, you can take this as u, this as v. I have no issue. So, when I want to take uv, what happens here? Y dash will become u derivative of v plus v derivative of u. I think simple case. So, y dash will be is equal to sine 3x into, now derivative of cos 5x. What is derivative of cos 5x? Minus sine 5x into 5. Do not forget the chain rule. Cos derivative is minus sine, cos theta is minus sine theta, and then inside is 5x into 5 plus cos 5x, and derivative of sine 3x will become cos 3x into 3. I do not think so anything is left out here. If you feel something, no, I cannot take anything common. So, you can just share the working y dash is nothing but minus 5 sine 3x sine 5x plus 3 cos 5x cos 3x. So, this is my final solution. I hope you got this point clear, children. One more pattern of you can do the sum here. 2 multiply by 2 divided by 2, 2 sin A sin B. Now, 2 sin A sin B, you can apply the formula 2 sin A sin B is subtraction of cos, right. So, you should get all the answers in terms of your sine, your cos. So, that answer might differ from here, but that logic is also correct. I am applying the class 11 formula, multiplying by 2 divided by 2, 2 sin A cos B is subtraction addition of sine, right. You can do that also and work out, and this also is fine. You can just go ahead with whatever working you feel comfortable with. This question I want to focus. So, this is actually chain rule only. I am not telling you much. There are two ways to look at it. I will tell you. Hold on. I will just show you both the ways. They are telling find dy by dx. Okay, of course. Now, in this case also they are asking you find y dash. Okay, I have no issue at all. I want you to pay attention on this. Y is equal to t cube plus 4, t is equal to x square plus 2x, find dy by dx. Now, important is they are asking you dy by dx, okay. One way is doing as the functions are given to you. What? If I want to find the derivative of this y, right, what is the derivative of y? But the available variable is t. That means you have to differentiate y with respect to t. So, dy by dt is nothing but 3t square. You have to treat this as x only now, correct? So, dy by dt is x cube. So, x cube is 3x square, power rule. Similarly, dt by dx I took the derivative of this function and this function separately, dt with respect to x. What is the derivative? 2x plus 2. Now, once you finish with this, as I am interested in dy by dx, if you look at this, tell me if you multiply, remember the differential coefficient notation is our symbolic notation, that's all. Okay. So, if I multiply this, dt get cancelled, I will get dy by dx. So, multiply these two equations. So, dy by dt into dt by dx will be is equal to right hand side to right hand side 3t square into 2x plus 2. So, now what happens now? This will get cancelled. So, what will be left out? Dy by dx will be is equal to 3t square. What is t given to you? X square plus 2x. So, 3t square, oh t square it is. So, x square plus 2x whole square into 2x plus 2. Now, definitely I hope you got this point. I replaced this t from the question because dy by dx I have written in terms of x completely. Now, you can simplify this. I do not think so anything much is there, but let me see whether I can really do the best simplification here. So, dy by dx will be is equal to say, now if I take 2 common here, 3 2s are 6, this will become x plus 1, and if I can take x, okay, I will just show you the working here of this. So, this is x square plus 2x whole square. So, what I can do is I can take x common inside. So, if I take x common inside, this will become x plus 2 and this complete square. So, if I take out common, this will become x square and this will become x plus 2 whole square. It is basic maths. I am not taking anything very abnormal in complex differentiation. I am not doing anything of that sort. Okay, as I said, what is the other way of looking at this question? Now, look at this function. So, y is given t cube plus 4, t is equal to x square plus 2x. So, what I can do is, this t I can replace in this. So, y will be equal to x square plus 2x whole cube, x square plus 2x whole cube plus 4. Now, find the derivative, 100% you are going to get the same answer, might not be the appearance would be the same, but if you simplify this and this answer, after you find the derivative, that is y dash is nothing but thrice of x square plus 2x into 2x plus 2. I think you are getting this square here, see this, the same answer you are getting this. So, what I did, the second method is, I took this t and placed over here, and that means everything got in terms of x, so I can find dy by dx. But this method also is important. Actually, I am doing the chain rule, nothing else. I found the derivative of this y and then I found the inside derivative, because inside derivative is t, that is dt by dx. So, I hope you got this point clear, children. Both the sums are equally good. So, pause and note it down. Okay guys, I hope you got this message clear. Let us take the next question now. Not a difficult one, it is a simple one, but I can see a lot of complicated functions happening. So, I just want to, okay, right. So, now x tan x upon sec x plus tan x. So, one thing I can do, see this is 1 upon cos plus sin upon cos, this is sin upon cos, cos can get cancelled. So, I just see, I told you beginning also that you can keep this as it is and go ahead with the solution, there is no problem. U upon v, but you have the full right to simplify the functions whenever you are whenever you are able to. Okay, nobody can stop you in mathematics. So, let us begin this wonderful sum there. So, what I will do is I can just pick up y is equal to x sin x upon cos x. I am converting into sin and cos because it becomes a little bit easier for me to handle this. Sec x is 1 upon cos plus sine. So, this will become 1 plus sin x upon cos x. So, eliminate this cos x here. So, this function will further get simplified to x sin x upon 1 plus sin x. That is it. I think I have to do u by v now. Okay, now here the catch is. Now, let us take about u by v. Okay, now let us see what do. Again, everybody knows what you have u by v. So, y dash v square. Oh, I beg your pardon here. Just went a little bit down. Right, u by v will happen now v square 1 plus sin x whole square. Go ahead with this. Now, write the working there. V derivative of u, clear, minus u derivative of v. Okay, I think I am very clear about this now. So, v derivative of u minus u derivative of v. Okay, great. Now, I want you to pay attention now something. Let us go ahead with the working. So, y dash is equal to what happens here? One plus sin x whole square right. Okay, now pay attention. V. Now, here I want you to pay attention now. Now, if you see in this derivative of x sin x, so here again uv. That means in u upon v, you are again inside doing uv. So, you can't ignore that rule till you end the solution, to come to the solution. So, uv again. So, that is what I want to pursue it further. So, what will happen now? I am writing this now, u derivative of v, that is cos x plus v derivative of x is 1. So, remember this 1 plus sin x into derivative of x sin x is x cos x plus sin x. I think that is very clear, right children? Okay, I do not get confused. Minus x sin x into, if you look at this, derivative 1 is 0, derivative of sin x is cos x. My job is over, because I think, I am sorry there, I hope you got this point. I think nothing else must changes here. So, y dash will be is equal to, now I am just keeping this as it is, because, or if you want, you can open this up, because this might cancel. So, 1 into this term will become x cos x plus sin x, and sin x into this plus x sin x cos x, x sin x cos x plus sin square x, because sin x into sin x equals sin square x, minus x cos x sin x upon, this will become 1 plus sin x whole square. Now, I think you can cancel this out, and eventually what happens, let us see. Oh, it is a big thing, there is no way you can work out anything further. So, y dash is x cos x plus sin x plus sin square x divided by 1 plus sin x whole square. I think nothing you can simplify here. Okay, I am sorry, I have just got glued in on the screen, because the thing is I have to be careful about working with the sum, and I want to show you that in u upon v again you got a situation where you have to do uv. So, that is what the message come. I think this type of sum had come first time, when in a particular u upon v or in a particular quotient rule you are again applying the product inside. So see, by this time you must have got a knowledge, must got have understanding of how we really go about with the working on this particular sums using the quotient rule, product rule and the chain rule. Don't to forget it. Okay. Now I hope you got this point, children. So pause and note it down. Okay guys, let us take the next question. But oh lovely, that's a break ke baad. I think you are very tired now. So let me give you a small break for 2 minutes and then we will go ahead with the solution. Okay guys, now level of the sums increases. Okay, very simple, but you have to stick what I explained to you, right? This is sine of 1 plus x square 1 minus, so it's a single term function. So as I said, if I want to find the derivative y dash, first outside derivative, what is sine of something? Sine of something is cos of 1 plus x square upon 1 minus, sine of anything will become cos of anything, right? So sine of anything, cos of anything into, hold on, this was the derivative of sine, the outside derivative, then but inside there is the algebraic function. So into, chain rule says derivative of the inside function 1 plus x square upon 1 minus x square. 1 plus x square upon 1 minus x square. I will not need this, but still I will write it down. So now go ahead and work with this now, how I do this part. So y dash is cos of 1 plus x square upon 1 minus x square into, now this is derivative of what? U upon v. So let us go ahead and apply u upon v, and what happens? Let us see. 1 minus x square square, v square, v, a simple function, I am directly taking the derivative, v derivative of u minus u. Now derivative of v, understand this was plus x square, derivative became 2x, this minus x square, derivative will become minus 2x. Don't forget that. Basic maths comes for the kill. So what happens now? Y dash will become cos of 1 plus x square upon 1 minus x square into, just see this part, 1 minus x square square, and what happens over here? 2x minus 2x cube, 2x minus 2x cube, minus into minus will become plus, so 2x into 1 is 2x and 2x into is 2x cube. So simple working, it's basic maths, again it is calling the accuracy or basic understanding, and I think I can just simplify this portion. Don't cancel anything out of this and this, because this is a part of the angle cos theta, this is theta. Okay, so y dash will become cos of 1 plus x square upon 1 minus x square into 2x plus 2x will become 4x upon 1 minus x square square. So I hope this is very clear to you all, right? So keep that in mind. This is the way you have to solve this question. I hope you got this point clear. So pause and note it down. Okay guys, next question now quickly. I am moving a little bit faster, you must have understood from the speed, right? But fine, now I think you are a little bit well versed with 10% of differentiation. So y dash, again u by v now, v square, v derivative of u right minus u derivative of v. Simple working. V derivative of u minus u derivative of v upon v square. Okay, now let us go ahead. So y dash, first I would always suggest put this out quickly, cot 2x whole square. Okay. Now cot 2x will remain as it is, cot 2x. Now when you come inside the bracket, it is a plus sign, so individual term derivative plays its role. So sin x derivative is cos x plus x square derivative is 2x minus, this will remain as it is, sin x plus x square. Now derivative of tan, I know it is derivative of cot. Derivative of tan is what? Sec square x. So derivative of cot 2x is minus cosec square 2x. This was derivative of cot, but when you go inside it is 2x, so into 2, chain rule. So first derivative of this trigonometric part, then you go inside, it is nothing but into 2. I hope you got this point clear. I hope it's very clear now. So what happens over here quickly, let us, I think anything can get cancelled here. I don't think so anything will get cancelled except for minus of minus will become plus. So I can just eliminate that portion and I can take this 2 up there. I don't think so any simplification is possible in this case. So my judgment is answering this. You can take this 2 in front of before sign. So it becomes easier, a convention which we follow in denoting the solution in a proper format. So I hope you got this point clear, children. Remember u by v, v square. I have not done anything abnormal or anything extraordinary in this question. It was a much simpler question than what we had done till now in the previous one. Remember one thing, whenever power is there, the first power derivative and then go inside and then you find the derivative of the remaining function. So I hope you got this point clear. So pause and note it down. Okay, next question. Oh, next question comes up here. Sometimes you are taken by surprise. So anyway, now here I am not that surprised with the sum, but definitely some surprise with the presentation. Question says fx is 9 sin x plus sin 3x, find f dash pi by 3. Now this is something important, I want you to remember this. You look, f dash pi by 3. See, at the most I can get f dash x. Correct? F dash x I can get it, right or not? So if I want to find f dash pi by 3, so I believe first to find f dash x. First you will find f dash x. So f dash x is 9 cos x plus sin 3x. Now when I say sin 3x, outside is sine. So first outer derivative, sine of anything is cos of that thing into chain rule, inside is algebraic function. So first sine derivative, then inside 3x derivative. 3x derivative is 3. So sin 3x derivative is cos 3x and inside 3x derivative will become 3. Happy. Now this is not they are asking you something else, they are asking f dash pi by 3. So once you find f dash x, so f dash pi by 3, you know what does this resemble in function? Many times we have done this when we are on to or something like that. F dash x is given to you, inverse of function, sorry. F dash x is f dash pi by 3. So replace x by pi by 3 in this question. Replace x by pi by 3, which is equal to 9 cos pi by 3 plus 3 cos 3 into pi by 3. So I think very simple now. I think you don't cancel this 3 and this 3 and this 3. This 3 will cancel over here. So f dash pi by 3 is nothing but cos, the pi is 180 degree, don't let me not tell you that, 60. So cos 60 is 9 by 2, right, because 9 into cos 60 is nothing but 1 by 2, pi by 3 is 1 by 2, right, plus 3. Now cos pi is minus 1. Now if you don't remember this, I'll tell you how. Cos 180, so cos 180 I can write as cos of 180 plus 0, right. So 180 plus 0, third quadrant, cos will be negative, so minus cos 0, that is minus 1. You can write 180 minus 0 also is the same thing. So it is minus 1. If you feel a little bit problem, you can use the calculator and quickly do it. So what happens now? F dash pi by 3, you have to simplify this out. LCM, if I take it, it will 9 minus 6 upon 2, 3 upon 2. This is my solution. So not a difficult case as such, because they are asking f dash pi by 3, I cannot get directly. So first you found f dash x from the simple function, these are simple function, and you pursued the sum further. So I hope you got this point clear, children. So pause and note it down. Take the next question. Okay, great. Whenever you have proof, I am the first one to jump in to solve the question. You know why? Because there are sometimes many challenges in the proving part. Now, by the way, I want to understand what is the proof. They are asking prove that x sine square x dy by dx is equal to x square tan x plus y sine square x. So it's a little bit catchy, this thing. Okay, the issue is what? Now, if you look at LHS, dy by dx you have to get from here. Take this dy by dx and place it in this. That's what it is, LHS, and prove LHS is equal to RHS. That's what the sum claims. So anyway, now let me see whether I can really get the proof. Proofs are always interesting to do because you need a little bit extraordinary applying of your mind to the sum. So x tan x, first of all let us talk about dy by dx because that's what I am asking. Dy by dx will be u, tan x derivative is x square x. I am doing uv rule, I hope you know this is u, this is v. U derivative of v plus v derivative of u. So my job is over. So I found the derivative. Now what I am going to do, I am going to come for the LHS. What is LHS given to you? X sine square x into dy by dx. So into dy by dx will become what? X sec square x plus tan x. My God. Now the point is, I need this to be simplified to do x square tan x plus y sin square. So that's why you're very careful what you are doing. What I can do is, I think I should get directly the answer here. I'll tell you how. Open the bracket. This will become x into x. See, because there is an x square here, x into x will become x square. Sin square x into sec square x. Now, sin square x, sec square x is nothing but 1 upon cos square x plus this will become x sin square x. I think it will become sin x sin, now this is x sin square x into sin x upon cos x, right? Okay, I just keep it as it is, sin square x sin. You know why I did this? I'll tell you. Because I will just tell you now. In this case, I want x tan x. So x tan x is already there. Okay, x tan x is already there. And what I can do now, okay, now you know why? I'll tell you. Now look at this, x tan x. What is x tan x? It is y. So that's why I told that in proving it that you have to really apply your mind. So x tan x is y. So here in this case I am getting x square. This I can write, okay, let me just see where what it reaches. Tan square x plus This will become x tan x will become y sin square x. Oh, there is a possibility of some error in the proofs. So, x square tan square x plus y x square, this is square. I'm sorry. Okay. So, I think this is nothing but RHS. Okay, I didn't change, you don't change the examination the sums will be proper. There might be some typing error, but from my side I will definitely verify about the authenticity of this mistake, right. If it's not there, then we have to prove this, but if it's there, please change the soft copy. Okay. So, right now my situation is that it has to be x square tan square x plus y sin square x. If I open the bracket, I am clearly getting the solution. Now, here the catch is, when see x tan x is nothing but y, correct or not? X tan x will be y. So, y sin square x will be the output here. So, be careful about it, be clear about it, and that is the way to absorb the solution. So, I hope you got this point clear, children. So, pause and note it down. Let us take the last question. This is not a difficult one, but definitely if you look at the proving part, might prove difficult, but it's not. So, let us see how we go about that. So, y is equal to 2 tan x by 2, prove that dy by dx is this stuff. Okay. Now, I have to find derivative of this. So, dy by dx is equal to, dy by dx is equal to 2 as it is. What is derivative of tan of anything? Derivative of tan of something is tan x, derivative is sec square x. So, this will become sec square x, tan x is sec square x by 2. Remember, hold on now, tan derivative is sec square, tan of anything, derivative is sec square of that thing, into chain rule says 1 by 2. Understood? I will show you. See, if it is, say, I will just show you, sin x by 2. What is derivative of sine of anything? Sine of anything derivative is cos x by 2. So, this is derivative outside sine, the sine derivative is cos, and when you go inside x by 2, what is derivative of x by 2? 1. This is a coefficient, you can't take it out. So, 1 upon 2. Keep that, don't make it 1 upon 4, this is a part of angle. This is a part of angle here. Okay, I hope you got this point. So, similarly here, tan derivative sec square x by 2 into 1 by 2. So, luckily what is going to happen now? This I can cancel it out. Now, the problem happens with this. Okay, I really don't know. I will share with you what I want to do. Dy by dx, I am just writing this. This can I write 1 upon cos square x by 2? Finish. Dy by dx, I got this. Now, this is the same thing. You might ask me, sir, how? I will just show you. See, this is the same thing. 2 upon 1 plus cos x. If you remember your trigonometric formula, what is 1 plus cos 2 theta? 2 cos square x. Class 11. What is 1 plus cos x? 2 cos square x by 2. Now, you may say, how you remember this? Remember one thing, 1 plus cos and 1 minus cos. You always have a formula. So, 1 plus cos 2 theta is 2 cos square theta. 1 plus cos theta is 2 cos square theta by 2. Don't by heart it. Double has become single. So, single will become half. So, cos x will become x by 2. So, my job is over. So, 2 upon, this will become 2 cos square x by 2. So, 2 gets cancelled. 1 upon cos square x by 2. I am talking about the right hand side here. So, left hand side derivative I prove 1 upon cos square x by 2. This simplifies to 1 upon cos square x by 2. So, if you have this, you can write this out. Now, you might ask me, sir, how I got this? Very simple now. Please understand this, what I am doing. Please. Now, see, I will just continue with this. Now, suppose you are not dealing with this, okay, because sometimes what happens, we don't know whether this we are not dealing, okay, right now. What I want to ask you something. Now, cos square x by 2. What is cos square x by 2? 1 plus cos x upon 2 is cos square x by 2. Agree? Okay. So, I am not simplifying that and showing you. This is just for your understanding. So, 1 plus cos x. So, dy by dx is 1 upon cos square x by 2 is 1 plus cos x upon 2. and this will go to the numerator. I got it. So, dy by dx is nothing but 2 upon 1 plus cos x. What I want you to understand from whatever sessions we completed on differentiation till now, it is just recapitulation of class 11 and definitely a little bit definitely higher sums than what you did in class 11. What you have to know is how to apply the product rule, how to apply the quotient rule, okay, and most important, the working. Anyway, now I am sorry I just went into that. So, I just wanted to copy it down quickly. Copy it down. Simple, it's not, I understand. So last step is something, but it's a good question. I am not say, it's a, what do you say, what do you call lightweight. It is very heavyweight sum, no doubt, because this formulas you keep in mind. This is important. This will come again and again in your class 12 syllabus. Okay, children, I hope you got this point clear. This was the last question, children, and I want to tell you something. Till now, whatever we had done, it was a slightly higher level than what you studied in class 11. But I would remind you something. If you understood at least 30 to 40% of the sums what we did, I believe you are ready to start with the class 12 differentiation. But let me remind you one more point, that this particular part of 25, 26, whatever sums we had completed, remember this covers everything of class 11 and a little bit higher level sums of class 12. Okay? And from here you begin with the new functions and you like log, e, logarithmic, parametric, implicit. So by this time, if you understood 30% of what sums we have done, same rule, same thing we are going to do in further part also. So just relax. If you understood 30% also, that's more than enough for me right now, because I know how to take you back to those levels after understanding this particular part of the 25 sums, working of 25 sums for you. So children, thank you very much for being with me, and God bless you all. I hope you enjoyed the lecture, and I hope we will definitely meet up in the next session saying something more and something different. Okay, so thank you very much. God bless you. See you. Bye bye.